Hi, I'm Steve. You can call me Steve. I live in the North. I've spent the vast majority of my life closer to the North Pole than to the equator. In all that time, I've seen the Northern Lights once, maybe twice, and it was a pretty pitiful display. Despite living at nearly 50 degrees north, I still wasn't north enough to properly see the aurora. I need to be at least 60 degrees north to see a good display, which in Canada is where most of the provinces end and the territories begin. The vast majority of the Canadian population lives far, far south of this line, and so never see good aurorae. I'm saying aurorae instead of auroras, because the name comes from the Roman goddess of the dawn, and that's how you pluralize a Latin word ending in A. However, this is a tad pretentious, so if you want to say auroras, that's fine too. The standard elevator explanation for an aurora is that it's the result of charged particles striking the atmosphere. I'm not a fan of this description because while it's technically correct, it completely fails to explain anything. What are these charged particles? Where do they come from? What is it about the atmosphere that makes them go glowy? First things first, the particles are debris from the sun. The sun is a ginormous ball of plasma or ionized gas. It's mostly hydrogen, and when I say ionized, I mean that in this case, the hydrogen ions have had their electrons ripped off. When you ionize hydrogen in this way, all you're left with is just a proton. The sun is a seething stew of free protons and electrons. This stew is getting continuously flung off the surface of the sun in all directions, and we call that the solar wind. When the solar wind gets to Earth, aurorae happen. It's not as simple as that, because before the wind can get to the atmosphere, it has to get through the magnetic field. This is a giant field generated by the lump of spinning metal at the core of the planet, and it protects us from the worst of the garbage the sun throws at us. Electrical things, like these charged particles, generally interact with magnetic things because electricity and magnetism are closely related. In this case, the interaction means that those particles don't make it through the field, except that there are holes at the poles. This last statement conveys a general idea while being wrong in just about every particular, so I'm going to call it a metaphor. Anyway, these holes are the reason aurorae only occur near the poles. Okay, the particles are through the magnetic field. Now what? Now they run into the outermost layer of the atmosphere, the ionosphere. It also has a lot of ionized gas, hence the name ionosphere. It's not the same roiling stew as the plasma on the sun, though. This stuff is a lot colder. Anywhere else in the atmosphere, these ions would run into enough other molecules that eventually they'd get electrons back from somewhere and everybody would be happy. However, the ionosphere is so diffuse that there aren't many other molecules up there for it to hit, so they stay ions. Electrons from the solar wind come screaming in out of the night looking for a new home, and they find these ions floating around with vacancies. In order for an electron to fill one of these vacancies, it needs to slough off a lot of the excess energy it's carrying. And it does this by emitting a photon of light. The color of that light is characteristic of the atom the electron is landing on. Nitrogen is blue and purple, maybe with a little bit of red thrown in, and oxygen is green, sometimes yellow or red in extreme cases. These two gases make up the vast majority of the atmosphere, so that's why aurorae tend to be bluey-greenish with maybe hints of yellow or red. There's a notion that an aurora is strictly a winter phenomenon. This isn't true. The solar wind is streaming in constantly, regardless of whether the pole is pointing towards or away from the sun. However, summer near the Arctic or Antarctic circles usually means near constant daylight, which makes the aurorae hard to see. They still happen, they're just washed out by the light from the sun. There's one more glowy thing in the sky that vanity requires me to mention. Steve. It stands for Strong Thermal Emission Velocity Enhancement, which I'm pretty sure are just 5 semi-random words they picked to fit the acronym. Supposedly it's named after a hedge in a movie, but I'm claiming it as mine. We Steves need to stick together. It's been observed for decades, but only in the last few years has it been studied enough to determine it's not the same as an aurora, and it's not associated with incoming solar particles. As best as we understand it today, sometimes the ionosphere just randomly lights up. That's aurorae. They're quite impressive if you can see them, but you have to travel a bit. They feature prominently in the mythology of the Inuit and the Athabascan-speaking peoples who live in the higher latitudes, because it's impossible to live up there and not be awed by how spectacular they are. They're not strictly a winter phenomenon. They're just easier to notice when there's more nighttime to see them in. Thanks for watching. I've been Steve.